Hi, so in this video we're going to see how to find the mathematical expectation which is also called the expected value or the mean of a random variable. So we say that we have let x be a random variable. So x is a random variable. So if you have any function u of x, so this is a function of x. So I'm just going to pick a general case. So most of the time you're going to have to find the expectation of x, but if you assume that for any function u of x, the expected value of u of x equal to the summation, this is for the discrete case, the summation of the x in the sample space of u of x, f of x. And this f of x is what we call the probability mass function. Again, it's the probability that x equal to x, right? So this f of x is the probability mass function, and it's the same time the probability that x take a specific value. So this is why I put x equal to x here. So if this function is just x, right, so we are going to have the expected value of x is going to be the summation of the x in the sample space of the x p of x, which is the same as the summation of the x in the sample space of the x f of x. And this f is the probability mass function, but in this case we are dealing with the discrete case. So let's say we have a specific function. For example, if you have example 1, we have f of x equal to x over 10. X can take the value of 1, 2, 3, and 4. So in this case, the sample sample space is this sample is the set 1, 2, 3, and 4, right? And this f of x, this is f of x. This is the probability that x equal to x, right? So, and to get that probability, we just replace whatever x by x in this expression. So if you want to find the expected value of the expectation of x, which is also the mean, so that's the population mean, because we are taking this from a distribution, this is going to be the summation of x in the sample space here is 1, 2, 3, 4, right? And then x f of x. So what we have to do is just to plot the numbers in, then get the expected value. So if you want to refer to that for that equation, we have therefore the expected value of x, which is equal to the mean, the population mean, is equal to the summation of x in the sample space. X, because f of x was x over 10, we replace by x over 10, right? If you see here, f of x is x over 10, so we just replace f of x by x over 10. And because this sample is 1, 2, 3, 4, right? So we're just going to replace x by whatever you have. So this is going to be 1 times 1 over 10 plus 2 times 2 over 10 plus 3 times 3 over 10 plus 4 times 4 over 10. That's the expected value. So if you sum this, you're just going to get 3. So this is our final result. So that's how we compute the expected value of a random variable. So let us say we take another case, another example. We are going to try again to find the expected value of that random variable. So if you have, let's say we have the function f of x. I'm just going to pick one function, f of x equal to absolute value of x plus 1 square divided by 9. In this case, s can take the value of -1, 0, and 1, right? So again, we understand the principle already. So the expectation of x is just going to be the summation of the x f of x, right? So this is going to be -1 times we do -1 absolute value, right? So this absolute value plus 1 square over 9, then plus 0 times times 0 plus 1 divided by 9. This is square, right? Then plus the last term is, again, we have 1 times absolute value of 1 plus 1 square divided by 9. So if you can see that this is going to give us 0, right? So we are left out with these two expressions. So this is going to give us this equal to, you can just compute that. It's just going to give us a -4. So the expression was, if you want to copy that back there, so this was -1. So we have a -1 here, right? And then inside we have the absolute value of -1 plus 1 square divided by 9, and then plus the last term was 1, right? 1 times we have the absolute value of 1 plus 1 square divided by 9. So the 0, if you look at this, we don't have this expression because the 0 cancel out this expression. So that's what we have. And look at this, because we have the absolute value here, so just this is going to give us 1. So this is going to be -1 times 1 plus 1 square divided by 9 plus 1 plus 1 square divided by 9, right? And you can see that it's the same thing, so this is just going to cancel out. We get 0. So this expected value, which is the mean, equal to 0 in this case. So that was very easy to find. Now if you want to use the same function, but you want to find, because you remember that I put a function like u of x, as I said something like u of x, then I said that the expectation of u of x was equal to the summation, that's for the discrete case, of the u of x and f of x, right? That's what I said. So for this particular case, if you in this case, if I want to find the expectation of maybe let's say x squared, right? In this case, you can see that u of x equal to x squared, right? So what we do is, the expectation of x squared is just going to be the summation of the x squared f of x. That's how you get it. Now we can just replace that in our expression and get the result what we need. So if you replace that in our expression, what do we get? So let's say we use the same function. We use the same function, f of x was equal to the absolute value of x plus 1 square divided by 9, right? So we are going to use the same function. So that's it. And the x take the value of -1, 0, and 1. So in this case, the expected value of x squared is just going to be basically is the summation of x squared f of x, which is going to be, the first one is just going to be -1 square, right? Then you replace by f of x, it's just going to be -1 absolute value plus 1 square divided by 9. Because this is 0, 0 squared is just going to be 0, so this is going to be plus. So 1 square. Then we have absolute value of 1 plus 1 all square divided by 9, right? So if we compare this, in this case, this is just going to give us 1. This is 1, right? So in this case, we are going to have so this is 1 plus 1 is just going to be 2 square, which is 4. This again, 1 plus 1 is 2 square is 4. So this expression, the expectation of S square just give us 4 over 9 plus 4 over 9, which is 8 over 9. Now, the reason why I was trying to find the expected value here, so if you can say that there's another relationship that you have to get out from here. So this is the expectation of x squared. So the variance, which is noted by sigma square, which is the variance of x, equal to the expectation of x square minus the mean, right, square. So if I want to get the variance in this case, the variance of x, because I already find the expectation of x squared, this is just going to be 8 over 9 minus, we find the expectation of x somewhere here, that was 0, right? So it's just going to be minus 0, so it's just going to be 8 over 9. That's how we find the variance. If you can find the expected value and the expected value of x squared, then from there you can get the variance. This is very important. So that was the second example. If you pick another example where it's a little bit more complex, let's say we have another example. Sorry for the noise. So let's say we have another example. The function is defined by so let's say we have a function that's defined by f of x equal to 0.9 if x equal to 0, and c over x if x equal to 1, 2, 3, 4, 5, 6, right? So what this function is we have an insurance company. So let me just specify the problem. So an insurance company sell an automobile policy. So we have an insurance company that sells an automobile policy with a deductible. So let me see, this is with a so we have an insurance company that sells an automobile policy with a deductible of 1 unit. So, and we said that let x be the amount of the loss. So this x is the amount of the loss. So we assume that the loss is defined by this function. So this function is the function that defines the loss, right? So that's how the loss function is defined. So the question is, so you can pause and read the problem, and the question is, determine the expected value of the amount the insurance company must pay. So let me start again. So an insurance company sells an automobile policy with a deductible of 1 unit we say let x be the amount of the loss. So the loss function is defined by that function, this function f of x. And the equation is determine the expected value of the amount of the insurance company must pay. So that's because this function is a priority mass function, and the expected value is basically the expected value of the loss, right, of the variable x, because x is the amount of the loss. So this question, what we are trying to do here, we are trying to find the expected value of x, right? That's what we need. So it's in other words, we are asking to find the expected value of the of x. So we saw how to find that. So basically the expected value of x equal to the summation of x f of x. In this case we have the x can take so x is in s, so in this case s equal to 0 1 2 3 4 5 up to 6, right? 6. The reason is you can see that this 0 also is there, then we have this specific value, so that's why I pick the sample s to be this. So this is going to be the summation. So it's just going to be 0 f of 0 plus 1 f of 1 plus 2 f of 2 plus 3 f of 3 plus up to plus 6, let's say plus 4 f of 4 plus 5 f of 5 plus 6 f of 6, right? So that's what we have. Because we have f of x, we can just plug this number in and then try to get our result. So f of 0, when x is 0, f of 0 is what? So when x is 0, when you go back here, when x is 0, f of 0 is 0.9, right? So this is going to be 0 times 0.9, it doesn't matter. So this is going to give us 0. So we are left out with this part. But when f is different than 0, when x is different than 0, x takes this value, right? So this, when x is different than 0, f of x is going to be something like this. So we go back here. So this gives us the expected value of x is going to be 1, and then 1 over 1 plus, so this is what we have here, c. Okay, so f of x is c over x, so this is going to be c over 1 plus 2 c over 2 plus 3 c over 3 plus 4 c over 4 plus 5 c over 5 plus 6 c over 6. But the problem is we don't have the constant c, so we must first find the constant c. And we know that the sum of probabilities should be equal to 1. So another property that we need, so what is c? We don't have c here. C, we don't have it. So we need to find c. And another property said that the sum of the f of x x in s had to be equal to 1. So basically this is saying that f of 1 plus f of 2 plus f of 3 plus f of 6 must equal to 1, right? Must be equal to 1. So that's it, because, and also f of 0, yeah, this is f of 6, so we start with f of 0 plus, right? Then we saw that f of 0 was 0.9, so this is going to be 0. So we're going to have 0.9 plus c over 1 plus c over 1 plus c over 2 plus c over 3 plus c over 4 plus c over 5 plus c over 6, right? So this must equal to 1. That's the sum of probability must equal to 1. So that's it. If you take c in parentheses, it's just going to be 1 plus 1 half plus 1 third plus 1/4 plus 1/5 plus 1/6 must equal to 1 minus 0.5. This gives you 0.1, right? So this is going to give you 0.1 because you said 1 minus 0.5, so you subtract 0.5 on both sides. This is going to give you 0.1. So you can just solve from C. You get C equal to 0.1 divided by, so this number gives you approximately 2.45. so this is going to be divided by 2.45, right? So you have C. In this case you have C. Since you have C, you can just go back here, then replace where was that? Then because you have C, you can just go back here and replace C by whatever you have, then just get the expected value. So I'm not going to do that. But if you replace this C, by the value that we get there, you are going to get the expected value of S, which is the expected loss that the insurance company have to pay. So that's what I have for this video, and this last one is a little bit complex. If you have additional question on that, feel free to post a comment so that I can respond to that. Thank you.